Hello, welcome to a talk titled CI/CD for Modern Applications. That's a pretty catchy title, right? They has CI/CD in the title, it has modern applications, but what does this all mean? I mean, are you going to talk about DevOps, Git, code pipeline? A bit of both, a bit of all those things. And yeah, I promise it's going to be a lot of different things throughout the talk, and also there's going to be a demo, so it's not just going to be PowerPoint. Let's actually answer the first question we may have. First question is, what is a modern application? How do you define what a modern application is? Is Instagram a modern application? Most likely. Is Amazon.com a modern application? Yeah. But what makes it a modern application? Well, it's not just the way you code it, it's not the way you develop it, it's also the way you deliver it, the way you architecture an application, the way you monitor an application, the way you learn from building the application. So there's a lot of little things connected to a modern application that makes it modern, right? And I'll get to the aspects and the pillars of a modern application as we go along today. But actually, let me take a step back and show you, or actually talk about, what Amazon did when it comes to a modern application in Amazon. So back in 2001, we had this big old monolith, the retail platform, so Amazon.com was this big old monolith application, and it was written by a whole bunch of teams, right? I believe it was at that time written in C++, and a big application that's written in C++, managed by a lot of people, a lot of teams, like hundreds of teams, right? It's complicated. So for us to move a bit faster, we decided to move to microservices, or back then we used to call those things primitives, and to two pizza teams. I'll get into two pizza teams in a moment, but what does this enable us to do? Well, this has enabled us to actually decompose for agility, or put ourselves into smaller chunks of things, chunks of services, even smaller teams, to be much faster, and not just faster in delivering software, but faster in innovating. Because you can imagine how difficult it is to innovate in a big old monolith, such as Amazon.com back in 2001 even. So, putting those things into microservices or nano services or whatever you would like to call them, and also making smaller teams, and hence the two pizza teams. So what is a two pizza team? So the definition of that would be, it's a team small enough that you can feed with two large pizzas. Now, it's very vague. How large are the pizzas? How hungry are the people? How large are the people, right? I can be a two pizza team myself on a Friday afternoon, right? So, but it's usually like 5 to 8 people, let's call them. This team owns this microservice, or maybe a couple of microservices. It has full ownership of that product they have. When I say full ownership, they have full ownership and accountability. So they own everything from infrastructure, to a point, to the way they develop, even the language they choose. Also, they own the way they interact with their customers. So no matter who the customer is, they own that interaction. There's no third party, team that does that and provide them with information, and then you do with what you wish. They do that with that. They practice DevOps, and also gives them the ability, because it's such a small team with such small, let's say, communication paths, that you can have this short way of interacting with your teammates, and which in essence gives you a better way to innovate, a better way to do things together instead of waiting for somebody in your team on a ticket or whatever, right? So, and especially these things kind of come into play when we talk about the development lifecycle of an application, especially an old application, which you have a monolith, and it's labeled services here, but that's not services. That's a big old monolith and a whole lot of developers committing code. And you commit your code, and once every quarter you deploy some code, and you just hope it all works. And if it doesn't work, it's a problem, right? How to fix that? How to fix this? By the way, Amazon.com back in 2001, it took 24 hours to compile. So yeah, you can imagine how long it takes for, big monolithic applications. How fast can you innovate on that? So to fix this, we actually talk about microservices, right? Little chunks of an application, little chunks of your monolith that do one thing or two things or three things, but that's the only thing they do. So that means when you make changes to them, you make the change only to that thing, and instead of having this big old pipeline that, like, you know, in the previous companies I used to work for, we had like a build server or a build setup where we have a single pipeline, everything goes there and just it gets built. It's horrible. Instead of having just one, you have multiple. You have a whole lot of delivery pipelines. Every pizza team has their own pipeline. Every microservice has its own pipeline. So multiple pipelines, multiple microservices, multiple small 2 pizza teams give you, well, the ability to have an innovation flywheel. What does this thing mean? Well, it gives you the ability to experiment, right? Try new things. Try, so, oh, I have an idea, let me implement it. It failed. How do I know it failed? I've listened to it. I was able to observe what the problem was because I deployed it, I owned everything around it, I know what broke. And then based on that, I iterate, make it better or completely scratch it and try again. You get this constant cycle of being able to experiment, see what happens, fix it or iterate, and do it again. So this brings your modern application. This brings your application to a modern application because you can effectively modernize it as you go and make it better in a very short amount of time, because time to market is very important in these days. Okay, you may be wondering who has been talking for the last 6 minutes and why is this bald person yelling at the camera? Well, to introduce myself, my name is Darko Meszaros. I'm a developer advocate at AWS. I'm based in Berlin, Germany, but I'm originally from Serbia, hence the multiple different types of spellings you can see there. I've been working for AWS for almost 5 years right now, and I moved on from premium support to solution architecture, and now I'm a developer advocate, and my job is to talk to you, our developers, our engineers, and get your feedback and input on the things we do, how we do them, and also at the same time, sometimes try to educate and entertain in places like this. And if you want more of this, please do check out my social media and YouTubes and Twitches and whatnots. I do a lot more content there, so if you're looking for learning more stuff on AWS, check that out for sure. Okay, I mentioned I'm gonna talk about some pillars about a modern application, I guess. Well, absolutely. So these pillars or kind of a best practices when it comes to making your application modern, you have to adopt 3 things. 1, microservices. Very important to have your chunks. Have you seen that right now? These chunks of an application, of a monolith that kind of help you move much faster. You need to improve your software delivery. Remember CI/CD? Yeah, CI/CD, infrastructure as code, all that fine stuff. And also, you need to change your operational model. Forget those servers, right? I don't want a cluster of things to run. Why? I want to do something maybe like containers. I want to do containers, or I want to do microservices. Hey, serverless, right? Do serverless. Do things that you don't have to care about. Don't focus on operating your massive infrastructure, because your massive infrastructure does not bring your modern application any value. Your code, the way you build it, the way you innovate it, brings its value. So let's talk about that. Serverless itself, right? Serverless is not just this and gone. No, serverless, there are servers in serverless, I promise, but the serverless is actually an operational model. There's no infrastructure to manage or provision. Infrastructure exists, but you don't care about it being managed or provisioned. You give it some code and let it run. In the way it's built, in the way it's architected, in the way it's designed, it's built for automatic scaling and high availability, right? That's how it functions. And the most important part of serverless is that you pay for value. You basically have almost no idle resources you need to pay for. You can bring your cost down to a cost per API call, which is just amazing, right? So that's really cool. And if you want to compare, like, what's an EC2 instance, what's a container, what's a Lambda function, or how does that fit into this? This is a really great slide where it shows like going from Lambda functions to EC2 instances. Basically, the less control you want, the more opinionated it is. Actually, the more opinionated it is, the less control you have. So if you run like a Lambda function, you just give it some code, right? And everything else is on us. But if you want a full-on EC2 instance, this is where you control everything besides the hardware. So this is kind of like an operational responsibility, and try to lower this down into you not having to worry about operations too much. Okay, so approaches to modern application development. There are 6 points here, and we're going to talk about a few of them today. We already talked about it. couple of them. So I'm just going to kind of breeze through this, but for example, simplifying environment management and reducing the impact changes of code is already covered with serverless and microservices. So these are some of the things we talked about before, right, in the last couple of slides. That's very important. But also, if you go back, gaining insight, understanding and listening to your application, observing your application is very important, and security is everybody's job. Hence, you build end-to-end security into your modern application. There's no like an endpoint that's secure and everything else is just a hodgepodge of FTP and Telnet. You build security straight from the get-go, right? But today, we're going to be focusing on these two things: automating operations and accelerating delivery of high-quality services with infrastructure as code and some CI/CD. So that's the talk of today. This is a long intro, I guess, but I promise we're going to get to the meat and potatoes of this talk quite soon. So let's talk about a release process stage. This is very important to understand because I need to grab a sip of coffee because I've been talking too much. So release process stages. When you release a piece of software, when you release infrastructure, you do it in, let's call it 4 stages: the source, the build, the test, and production. The source is your code repositories, the build is your unit testing and your, let's say, well, your builds, actually your compilations, if there is such a thing in 2020. There's where you do like some container builds and all the stuff. The testing is your integration testing, penetration testing, UI testing, acceptance testing, whatnot. And finally, production is a safe way to deploy your code into production, right? When we talk about CI/CD, what does it stand for? Continuous integration? Yeah, absolutely. But there's also continuous deployment. There's continuous delivery, but we're not going to talk about delivery today. Basically, CI/CD is continuous integration, continuous deployment. This is how they differ, but they're the same. You cannot have continuous deployment without CI. So yeah. So basically, continuous integration takes you through the source and the build phases, gets you an artifact, while the continuous deployment gets you from source to production all in one go, right? That's very important to keep in mind because these are the key aspects of your application delivery. Now, let's talk about pillars of releasing your application, modern application. Because releasing a modern application is not just making sure your code goes to the right place. There's also the part which is infrastructure. And infrastructure is more part of your application now than ever, especially thanks to serverless. Everything as infrastructure is part of your application, so we need to treat it as such, right? So we need to deploy it through code, right? So let's talk about infrastructure as code because it's a key thing in a modern application. So what is infrastructure as code? It basically gives you the ability to define infrastructure, define the resources and the IT resources, IT infrastructure that you run on, especially in the cloud, as a piece of code, something in a template. In essence, this gives you the ability to have a very predictable and repeatable way to make changes to your infrastructure. It also gives you the ability to deploy that infrastructure in the same way, in the same manner as you deploy your application. And finally, replicating your production, replicating environments or managing environments is much more simpler when you have them in infrastructure, especially if you ever had to deploy production to development or staging manually. It's a mess, right? So when you have it in a template, it's just so much better. Right. When I talk about infrastructure as code or ISC, I cannot escape but to talk about AWS CloudFormation, which is somehow escaping this thing. Don't do that. Thank you. That should be fine. AWS CloudFormation is a service that basically allows you to create infrastructure as code. When my slides keep running away, gives you the ability to make infrastructure as code for some reason. I'll leave it here. So CloudFormation gives you the ability to define your infrastructure as code through YAML or JSON files, right? You write these lovely YAML/JSON files, and those things basically where you describe the way you want your EC2 instances, your VPCs, your S3 buckets, your Lambda functions, anything you do, you define them in those things, and then you leave it to AWS to provision these things for you. They can also, as you can see on this slide, sit in a proper pipeline where people can actually commit that code to a repository, and it will actually go through a pipeline. And as you deploy your application, you also deploy your infrastructure, right? Now, I cannot talk about CloudFormation and serverless without mentioning CloudFormation's younger little brother, SAM. SAM is the serverless application model. Basically, it's the same thing as CloudFormation, but it's very much focused on serverless because it has specific transformations and functions that allow you to do better things for serverless applications. Here's an example. This is a simple SAM template that creates a Lambda function, an IAM role, an API gateway, and a DynamoDB table in 20 lines of code. So you can do this with vanilla CloudFormation, but it takes so much longer. So SAM is a focused infrastructure as code, or actually it's a focused version of CloudFormation for serverless applications. On top of that, SAM has a lovely SAM CLI, which allows you to do many things, from creating an application while it actually initializes a directory for you, to actually running serverless applications locally. It basically uses Docker to emulate Lambda functions locally on your workstation. It also can do the same for API gateways. So if you want to do those things locally, you can with SAM. But where SAM actually fits the best is in your pipelines, right? So you put things like building and packaging and deploying your SAM applications in like a code pipeline or in a Jenkins workflow, something like that. This is where it works. And as a bit of extra features, if SAM CLI also has the ability to do logging, or actually gives the ability to pull down logs from the Lambda function locally, so that's very cool. And if you're a fan of the serverless application repository, or SAR, running SAM publish will publish your SAM application directly to SAR. So no good tool exists without CLI. SAM has a CLI. Very good. Okay, last piece of ISC. Maybe you don't like JSON. Maybe YAML ain't your thing, right? You know, they say, hey, you know, it should be readable. I don't think JSON is readable, human readable at least. So maybe you're so amazing in Python that you want to use Python to deploy your infrastructure. Fair point, right? Maybe you just are an expert in Python or in JavaScript or some other language. Well, there is a service called the AWS Cloud Development Kit. Now, the AWS Cloud Development Kit enables you to use generic programming languages such as JavaScript, Java, TypeScript, Python, C#, F#, and Golang coming soon. It gives you the ability to use those existing tools and workflows and your knowledge in these languages to deploy infrastructure as code. Now, on top of that, it's a fully multi-language thing, and you can expect more languages to come as we go. And as you can see, the example code here, it's a simple JavaScript code. Actually, this is TypeScript, but you can use all the benefits of a programming language, such as reading off disks, doing some more complex functions or looping or conditionals or whatnot inside of your code, because at the end of the day, it is just generic programming language, and it supports things such as testing and whatnot. But this is not reinventing the wheel. The way this works, actually, it has a CLI tool. You write your applications, which consists of stacks and resources, like you define your resources within stacks, within applications. And again, everything that CloudFormation supports, CDK supports. And why? Well, because CDK actually uses CloudFormation. CDK generates CloudFormation templates or synthesizes CloudFormation templates for you, and then lets CloudFormation do the provisioning. Because why should CDK do all of this for you when there's no need to do that? Let CloudFormation handle that, and CDK will just give you the benefit of actually deploying things through lovely Python or TypeScript or Java. So yeah. Speaking of TypeScript and Python and Java, let me actually show you some CDK code. I'm gonna make a short jump cut here because I want to switch to a different laptop. So anytime I do a demo, you'll see me just pop into something else. Yeah, let's quickly have a look at some CDK code. Welcome to the first demo. Hope you enjoyed that, some movie magic there. So I'm going to show you some CDK code right now. It's going to be a really quick thing. Let's have a look at, I mentioned Cloud Development Kit, so let's have a look at how CDK code looks. So I'm going to open up in this directory here. I have a sample, well, actually not a sample, a CDK application that I've actually used for the demo later on. So if we look, especially this really differs when it comes to like different languages, but I'm going to show you like the TypeScript example. But in general, the way you use your code should be the same. Number one, we define a thing called an application in CDK. An application consists of one or multiple stacks. As you can see here, I've defined a single stack. It's called CFN pipeline stack, and it is just, hey, it's using a single stack in this case. If I want to have multiple stacks, I can also define the multiple stacks from the same stack. So in essence, this will create multiple CloudFormation stacks with the exact same resources. But I don't want to do that. So I create a single application and a stack. Now, where does this stack come from? So if I open up this, and actually, no, I have to go whoops, nope, back. I close this, no changes. If I go back to my lib directory and open up my CFN pipeline stack. Now, this this CDK application actually deploys a full CI/CD pipeline for the demo later on. You can see that this is where you define the actual code. So you basically get an empty file with this little comment saying this is where your code goes to. And you can see things that I define, like, for example, I create a Lambda function like this, right? I say, hey, this is my new constant, this is my a Lambda function. It contains, it runs, uses the Python runtime. This is the handler I'm going to be using, and the code is actually being read off disk from a directory called lambdas from a file index.py, right? And if I go down, like, I'm actually adding role policies to my Lambda function. I'm creating like a new code commit repository. And finally, I'm creating my pipeline and a whole lot of different things. Now, in this single file, there's 156 lines of code. But in essence, this will generate much more CloudFormation code. And yeah, so again, this is not a CDK demo. I just wanted you to have a look or taste how CDK code looks. It looks different depending on, is it Python or C or TypeScript or Java or whatever, right? But in essence, the way you define your resources are roughly the same. So yeah, I guess we can go back to the presentation. And we are back. Okay, hope you enjoyed that little short demo. Okay, let's move on. We finished up with infrastructure as code. Let's talk about continuous integration, or CI. If we recall on our old slide here on our release steps, CI basically envelops source and build. Now, what is the goal of CI, or continuous integration? Well, it's basically, the goal of that is to automatically kick off anytime there's a check-in to your repository. The code should be built and tested, like things such as unit tests, like some static way of testing your code, should be built and tested in a very consistent way. And what CI should enable you to have is an artifact ready for deployment. Once you have built an artifact here, you can deploy it to a staging environment, even to a development environment where you can continue working on it. But again, it gets you the ability to have those things quickly, and some people don't even go for the full CI/CD, they just have a CI pipeline. Then there are some other methods to do your proper deployments, right? So what parts of AWS can help you in CI? Well, the most important thing is the pipeline, the thing that orchestrates all of itself. And Code Pipeline is the service for you. Code Pipeline basically gives you the ability to model, visualize, and set up your full CI and CD process. In essence, it can kick off like once a code has been checked in somewhere, or an object has been dropped in S3, or if there's a push in the Docker repository, Elastic Container repository of like a Docker container image, actually. So once that happens, the pipeline itself can be triggered. And here's a great example of, like, hey, I commit my code in the master branch, or I put an image in my ECR repository, then something happens within my pipeline, right? And again, those things can be, well, as I mentioned, containers, commits, or S3 things, but also it can be anything. It can be webhooks, it can be even CloudWatch events, and a whole lot of things can actually kick off a pipeline. Because everything is API driven, it can be basically anything you want. Another aspect, and very important aspect of the entire pipeline, is actually the build stage. And the service that handles that is Code Build. In essence, Code Build is this fully managed way of building code. What happens here, you get provisioned a container, you don't have to worry about it, right? You give it some code, you give it an input artifact, you give it instructions what to do with that code, and it gets you an output artifact. So in essence, it's a container where you run arbitrary commands in with some artifacts and output artifacts. It's really great because there's nothing to manage. You just give it, here's my code, please do this, and go away. So it is really, really cool. Again, everything runs in a container. You don't have to worry about too much, but you can also improve upon it by adding your own custom built environments that suit your needs. So speaking of instructing code build what to do, it uses this thing called build spec files. Build spec files basically are YAML files that say, hey, at this phase, do that. Like install pip, or actually, sorry, install CLI. And this is a great example of doing Lambda with SAM. Like install CLI, build my SAM application, and package my SAM application in an S3 bucket, and something else in the pipeline will continue to do that, right? Here's a great example also how to do containers. A lot of people, when they do code build and with containers, what they do is actually they build the Docker image on code build and upload that Docker image to ECR through code build. So, and simple as that. This can be any command you want. So people have been very I would say very inspiring when they build Docker. When they build code build run commands. You can do a lot of things here. So very useful. And it's very key in the entire CI process. So kind of taking a step back to our goals, we can automatically kick when new code checks in. Code pipeline handles that for us. We can build and test our code easy with code build. And at the same time, we can have that artifact that's built by code build somewhere in an S3 bucket or wherever we would like to store our artifacts. And on top of that, we're constantly being notified if something fails and why it failed, or if it has succeeded, what are the outputs of that success. That's CI. Let's talk about the other C in CI/CD, and that's continuous deployment. Continuous deployment is very important, and this is, I would say, most people apply for complete CI/CD where they have a full deployment pipeline because it just saves so much time and effort. So, talking about continuous deployment and our phases of software delivery from source to build to test to prod. Continuous deployment covers that all, right? From actually source and build to test and to production. So on top of just having CI, we need to have additional things where we can expand our deployment, right? We need to have the ability to test even more. And then finally, we need to have the ability to safely deploy our application to production. And what can we use in AWS to deploy our application to production? Well, like all the fun names we have here is we have co-deploy, right? And I'm going to be speaking that in a second. But continuous deployment. What are the goals of continuous deployment? It's very simple. It's very similar to CI or continuous integration, but actually it should automatically deploy all the changes you make to your code, all the things that are being built in the CI phase, to staging environments for testing. So not straight to build to production. And especially once you're actually deploying to production, it should do it so safely that it does not impact your customers. When I say safely, it should test before deploying and also give you the ability to roll back if something goes wrong, right? And with this ability, with the ability to deploy rapidly and roll back if something goes wrong, you can deliver to your customers much, much faster. All the improvements you made and tested for can be deployed with a much higher frequency and not every 3 months, right? So speaking of co-deploy, this is a really neat service that deploys code to any instances and Lambda functions and containers on ECS. So co-deploy is the kind of the big old service that can do all of these things for you. So from deploying code to Lambda functions to ECS to EC2 instances, it handles all the complexity of the deploying code. It also handles the complexity of rolling back code, and it can also handle things such as canary deployments to Lambda functions only at this time, and it can handle the blue-green deployment strategies, right? So, and it can run basically on anything from Lambda functions to EC2 instances to containers to even your lovely on-premise instances or containers or whatever you would like. So how does this actually work? Especially, let's have a look at how this looks for Lambda. This is a snippet from SAM, or the Serverless Application Model. So if you've been paying attention, the infrastructure as code, service, or tool, SAM, gives us the ability to define a bunch of things like functions, DynamoDB tables, and whatnot, but also it allows us to actually define deployment preferences for our Lambda applications. And we can, for example, we define a canary deployment of our Lambda function, right, of our serverless function here. There's a bunch of different ways you can do it. You can do canary, you can do linear, or you can do it all at once, which sometimes works. But I'm going to explain canary deployments. So what are canary deployments? First of all, let's talk about the origin of canary, of the word canary. Canary is this yellow bird, right? In the olden days, miners used to, dig coal mines, and one of the things they would do is they would bring a cage with a canary inside, and they would, as they dig, they would move the canary along with them, and as long as the canary was singing, it's fine. As soon as the canary stops singing, most likely it's dead because of methane, right? And they had to really roll back really, really fast if that happens. So this is the same way. Canary deployments actually enables us to test the waters before we fully commit to production. And here's how it actually looks. So here's an API gateway, a Lambda function that's alias that's live, and our Lambda function code, right? We have an alias that points to a code. So once we make a change, and right now all of our traffic is going to our version 1 code. So we introduce version 2 code. Basically what happens here, we run a pre-traffic hook that says to the alias, hey, switch 10% of our traffic to the version 2 code. And what happens, we're waiting for 10 minutes right now in case an alarm happens. An alarm, it can be anything we define. Basically, we're monitoring for business outcomes or for application outcomes to see, has this code change broken while still serving 90% of our customers with the old code base. So, we're sure it runs. Then once we have actually, the 10 minutes have passed and the canary is still alive, we can switch the traffic, run a post-traffic hook, and basically complete our deployment, move all the traffic away from version 1 to version 2, and we have a successful canary deployment of our code. When it comes to ECS, or Elastic Container Service, you have the ability, and this also works for EC2, you have the ability to do blue-green deployments. Blue-green deployments are basically a way of spinning up a copy of the existing resources. So if you have like 5 tasks, 5 containers running, what happens here, you spin up additional 5 containers with the new version of the code, make sure it all works, and then terminate the old ones and bring the new ones into traffic, right? So it has the ability to do those things. Again, it has the ability to roll back if something has gone wrong. You basically just switch over traffic to the old ones, and you're fine, right? And to see how this looks, here's a great example. I have an application load balancer. I have a listener that listens to port 80, and it's actually going to a target group, which consists of containers on Fargate, for example, right? Running an ECS Fargate. It has they're called blue tasks. It's version 1 code. I start deploying another version of my code, and what it creates a test listener. It creates an additional listener to my load balancer, another target group, and this target group is actually deploying it provisions additional set of containers, additional 5 or 3 or how many tasks I need, called green tasks, and with the version 2 code. I basically pass not my production traffic, but my test traffic. I send my test traffic here just to make sure multiple different hooks, I can have people manually test this to see if it works. And then once this is fine, I flip my traffic, basically my listener, I flip it from target group 1 to target group 2, and hence now my traffic is serving target group 2, and the green code is now V2 code. So in essence, it's very similar to Canary, but in Canary we're actually deploying production traffic to our sample code. In this case, we're just having test traffic to our new code, and we have a complete copy of our infrastructure, which is very convenient when it comes to containers and EC2 instances. So back to continuous deployment goals. So the goals of continuous deployment, again, very similar to the ones in CI, but additionally on top of that, we have to be able to deploy all the code we commit to staging environments, not to production straight, but to like staging or development environments. And once we want to deploy it to production, we want to make sure that we deploy it very safely with the ability to roll back and have the ability to keep on deploying as we make new things, so we can bring value to our customers as fast as possible. So that would be from continuous deployment. And I think it's time for me to do a really quick demo right now. I'm going to show you some lovely CI/CD stuff with maybe some infrastructure as code and a whole bunch of things. So like before, I'm gonna actually make a lovely jump cut or some movie magic here, and I will be back in a few minutes. And we're back. I really hope you enjoyed that demo. And the most important part of the presentation, time to wrap up. So, takeaways. There's 4 takeaways I want you to take home from this. Number 1, manage your infrastructure as code, because infrastructure in 2020 is code. Use the same tools you can have for application delivery, use the same things for infrastructure delivery. Frequently build and integrate. Make sure to keep on having a ability to build, test your code as soon as possible so you can have really fast feedback if something fails. You do not want feedback when things go to production. When you keep on releasing into production, do things with Canary or blue-green so you can have constant monitoring of the new code and the ability to roll back without any fuss. And finally, when using Canary deployments or blue-green deployments, make sure you get your both technical and business feedback, because we sometimes focus a lot on the technical side of things, like, oh, well, I can just make sure my monitoring is fine, I don't have my CPU utilization too hard, or my disk IOs are fine, but I'm not achieving business outcome. Make sure to monitor for business outcome as well, or getting business feedback. All right. Well, I hope you enjoyed this presentation. It's been fun for me to deliver. Feel free to send me any feedback on the social medias you see there. And again, as I said before, if you're interested in listening more to this bald person, check me out on Twitch and YouTube. I do a lot more content there as well. My name has been Darko Meszaros, and I hope I'll see you at some future conference, maybe even in person. Bye-bye.